reinforcement learning. So we have components in reinforcement learning. So here are some important terms you need to know in reinforcement learning. The first is the agent. Now, an agent is anything which takes decision based on the rewards and punishments in order to achieve goals. So that is an agent. Now we have the environment. The environment is the world throughout which the agent moves. And we have the action. Action is all the possible steps the agent can take, either going or going down, running, shooting. Those are actions that the agent can take. Now, reward. Reward is an immediate return given to an agent after performing a specific action or task. Yeah, sometimes the reward is actually when the agent takes a step, but there are some times that the reward is actually at the end of after completing a specific task. That is when the agent gets a reward. So we have the state. Now the state is referred to as the current condition returned by the environment. So the particular place the agent is the state where the agent is in. So we have So now we have how reinforcement learning works. So now from the components I talked about, this is the mouse is the agent. Now where the mouse is what we call the environment. And now you can see from our point system, the actual reward, it actually gets reward when taking some actions, but the final destination is to get this cheese. So before getting this cheese, it will come through some obstacles. Like you can see this image of like tiers is plus 50. So when the mouse should get to this tiers part, it gets plus 50. But if you get to this like thunder sign, it gets minus 100. So now this agent can take years or can take 100 steps. It can take a longer time for this agent which is the mouse to get to his destination, because it's actually learning on his own. So it might take a particular action several times depending on how it's being able to learn and how its environment is. So now for the mouse to be able to get to its destination, it has to pass through all these obstacles to get to the destination. So how it works is that the mouse takes an action, and taking this action, it's being able to understand what to do. If it should get to this thunder sign and it gets minus 100, it's going to understand that, oh, I'm not supposed to get to that part. So if it's going to go back to that, maybe sometimes it can reach that place and go back, then go forward. So it's trying to understand the environment and how it's going to be able to get to its destination. So we have some learning models in reinforcement learning. So there are two important learning models in reinforcement learning. We have the Markov decision process and we have Q learning. So a Markov decision process, which is MVP, it provides a mathematical framework for modeling decision making in situations where outcomes are partly random and partly under the control of the decision maker. So actually, this Markov decision process is a mathematical framework which helps the agents to take some decisions. An agent can take several times or several actions to get to its destination. But with the help of Markov decision process, it limits its action. So instead of, let's say, an agent takes, okay, it wants to get to a destination and it has taken like 250 actions just to get to that destination. But with the help of Markov decision process, it helps it to take just like, let's say, 100 steps or 100 actions to get to its destination. Now we also have Q learning. Q learning is a value-based method for supplying information to inform which action an agent should take. Now you can see on my screen, we have these are 5 different, let's say 4 different rules. Why the 5th one is the way out, is where the agent is going to pass out, like to complete his tasks. But now, if we should leave the agent here, the agent can take several actions and it will waste time. So what Q-Learning does is that it supplies information. Now this is the information it supplies. This is like a map showing it how it's going to take its action to get to its goal. You can see if it takes from 2 to 3, from 3 to 1, from 1 to 5, it's going to get to its goal. Or it can take from 0 to 4 and from 4 to 5. That is the shortest route. So this Q-Learning actually helps. It supplies information to this agent on actions to take. Now, this is what Q-Learning does. From the definition, it's a value-based method. So it places value. So where there's 100 are the places where it's directly connected to the goal. You can see on my screen. Now, from 1 to 5 is direct to the goal. So if it wants to go, it can go from, let's say it's starting from 2. So it goes from 2 to 3, from 3 to 1, then from 1 to 5. So places where it's 100 are the places where it's the shortest route for it to pass. You can see from 0, so from 4 to 5 is direct, but from 5 to 4 is 0. So this is what Q-Learning does. It supplies information to the agent on actions to take. Now, conclusion. So I said reinforcement learning is a machine learning method. It is also called the science of decision making. It helps you discover which action yields the highest reward over the longer period. And reinforcement learning also provides the learning agent with a reward function. Reinforcement learning method works on interacting with the environment, whereas the supervised learning method works on giving sample data or example. So thank you. So are there any questions? Hello, can anyone hear me?
Yes, can hear you.
Okay. So are there any questions from you?
I think I have one over. I don't want to access. Can you hear me?
Yeah, I can hear you.
Okay, so I think though I didn't really have very fully enough presentation, but I think I can pick up one or two. So you introduced machine learning, how well they make better predictions and the likes. So I would just like to know what are the limitations to the current machine learning algorithms that are available, and what are the modern solutions to those, and how well do they optimize those algorithms?
So you said, hello, Mohammed.
Yeah, did you get that?
I didn't get the question. You said the challenges.
I said what I said basically was that since machine learning algorithms are there for us to make better predictions and analysis on data, so if are there any limitations to how well they make these predictions? And if there's any limitation to that, what are the best options to improve a machine learning algorithm?
Okay, so yeah, there are challenges and limitations to machine learning algorithms. Like when we talk about unsupervised learning, unsupervised learning, like for you to be able to, for your machine to be able to predict all the data very well, you have to like for supervised learning, you have to feed it labeled data. So that is actually easy for it to understand. But for the unsupervised learning, it's time consuming. It takes a lot of time for the machine to be able to understand some of these things, be able to know what to do because it's an unsupervised learning algorithm. But I think solutions. I don't know if there are any solutions to that, but I've not really done research on that, looking at the solutions that can help these machines to make accurate predictions. But after my research, I could maybe send you like an answer to your question. Hope you understand.
Okay, it's all good. Yeah, thank you.
All right. Thank you, Michael, for today's presentation. It's almost time for stand-ups.